Okay, this is section 6.2, right triangle trig, day number 2. Trig identities. In trigonometry, a great deal of time is spent studying the relationship between trig functions or trig identities. And we've already touched a little bit on this reciprocal identity idea. If we take the sine function and reciprocate it or flip it over, we get cosecant. So sine is really 1 over cosecant. Cosine and secant are reciprocal identities. So cosine is 1 over secant. Tangent and cotan are reciprocal, so tangent is 1 over cotan. And then all of these can also be flipped. The cosecant is 1 over sine. Secant is 1 over cosine. Cotan is 1 over tangent. As far as quotient identities go, the first one here, this is the most useful. Another way to look at tangent, we said tangent is 1 over cotan. Another way to look at tangent is sine divided by cosine. And also cotan can be the reciprocal of tangent. So where tangent is sine over cos, cotan can also be cos over sine. And we also have a couple or several Pythagorean identities, like a squared plus b squared is equal to c squared. We have something also occurring with these trig functions, where sine squared plus cosine squared is equal to 1. And then we have 1 plus tan squared is equal to secant squared, and 1 plus cotan squared is cosecant squared. But of these three, by far the most useful, the one you'll be seeing the most of, is sine squared plus cosine squared is equal to 1. And down here, a little notation thing, because, these trig functions, we've never looked at them as, something that we were squaring before. Down here it says, note that sine squared of theta represents sine squared quantity, or sine of theta quantity squared. So when we're looking at a trig function, sine squared of some angle theta. Another way to write this is to take that square and move it outside the parentheses. If the parentheses were not there, that is something entirely different. If I move those parentheses away, this is the sine of some quantity squared. And that's not what we want. This is the quantity sine of some angle theta, that quantity squared. So here in example 4, it says, let theta be an acute angle such that sine of theta is equal to 0.6. Find the values of first cos theta and b the tan of theta using trig identities. Well, we're given sine here, and we want to find cos. And what ties that together would be this Pythagorean identity right here. Sine squared plus cosine squared is equal to 1. So for part A, we know that sine squared of theta plus cosine squared of the same angle is equal to 1. And we were given that sine of theta is 0.6. So 0.6 squared plus cos squared is equal to 1. And if I square this, I get 0.36, and I'm going to subtract that from both sides. So the cos squared of theta is equal to 1 minus 0.36. And that's cos squared theta. 1 minus 0.36 is 0.64. And now we have a quantity squared, and we just want cos, so we will square root each side. So the cos of this angle theta is 0.8. So that was part A. We found cos theta. Part B, it says find tan theta. I'm going to just come up here. I'm going to write the cos of theta is 0.8 and clear this out. Okay, for part B, it says find tangent. Well, back to these new identities here. Tangent is equal to sine divided by cosine. So the tan of theta is equal to sine over cos of the same angle. Well, sine theta was given, 0.6. Cos theta we found in part A, that was 0.8. And if you punch that into your calculator, we'll find that the tan of angle theta is equal to 0.75. In example 5, it says let theta be an acute angle such that the tan of theta is equal to 3. Find the values of cotan and secant using these trig identities. Well, let's see here. They gave us tan of theta is 3. And first, part A, they want us to find cotan of the same angle theta. Well, if we back up a couple pages here, cotan is 1 over tan. So we take the reciprocal of tan, that is equal to cotan. And let's see here, we got the tan of theta. Tan of theta is 3 over 1. So cotan is equal to 1 over tan theta, or 1 over 3. Cotan of theta is equal to 1 over 3, 1/3. For part B. Part B says find secant. We want to find the secant of theta, and we have tangent was given, and we found cotan. So we need something that ties secant and tan together. Aha. Right here we have 1 plus tan squared equals secant squared. 1 plus tan squared is equal to secant squared. Well, we know that tan is equal to 3, so this becomes a 3 quantity squared. 1 plus 3 squared equals secant squared. Well, 3 squared is 9, plus 1 is 10. The secant squared of theta is equal to 10. And we have secant squared, but we want just plain old secant, so we square root both sides. And we find the secant of angle theta is equal to the square root of 10. Now, to evaluate these on the calculator. When evaluating a trig function with a calculator, you need to set the calculator to the desired mode of measurement. Remember, degree or radian. Make sure that calculator is in the proper mode. Most calculators do not have keys for the cosecant, secant, and cotan functions. To evaluate these functions, we can use x to the -1 power key, or that is x inverse key. The basic calculators that we have in class, we could also use the 1 over x key. That will take whatever you punch into the calculator and just find its reciprocal. For example, if you want to evaluate the cosecant of pi 8 radians, first we want to make sure we are in radian mode, and then we use the identity. The cosecant of 1/8 pi radians is 1 over the sine of the same pi 8 radians. So to do this on the calculator that we use in class, you could just punch in pi divided by 8, hit the sine key, and then use the 1 over x key. And that will give you the value of the cosecant of that same angle. Here's just a couple you can try on the calculator. Make sure you're pushing the buttons correctly. It says find the sine of 76.4 degrees, so we want to make sure we are in degree mode. We just punch in the number 76.4 and hit the sine key. And the display should have 0.971961. If you don't get that, the first thing I would check is your mode. Make sure you are in degree mode. For another one, cotan of 1.5 radians. So there is no cotan key. We want to use the tangent key. First, make sure you are in radian mode. We would do 1.5. Then you'd punch the tangent key. That gives us the tan of that radian value, and then we'd use the 1 over x key. And our display should have 0.0709148. And let's see what, I don't remember what this is here. When evaluating trig functions with a calculator, remember to enclose all fractional angle measures in parentheses. For instance, if you want to evaluate sine of theta, for theta is pi over 6, this pi divided by 6, we want to make sure we give it its own grouping symbols. We want parentheses around the pi over 6. So on our calculators, you'd do parenthesis, pi divided by 6 equals, and then hit the sine key to evaluate that angle measure. The keystrokes yield the correct value of 0.5. Note that some calculators automatically place a left parenthesis after a trig function. Check the user's guide for specific keystrokes you want to use. Here's a couple more examples. There are some homework problems that did not have matching examples in the book, so I just want to take a quick look at a few of these here. Cosine. Cosine of theta is 1/3, and they're asking us to find the sine, the tan, the secant of that same angle, and the cosecant of its complement. Well, let's see here. The first one, we're given cosine and we want to find sine. So for part A, I would use the Pythagorean identity, sine squared plus cosine squared of theta is equal to 1. Let's see, our cosine is 1/3, so cosine squared will be 1/3 squared, or 1/9. And sine squared plus that 1/9 is going to equal 1. Plus. So if I subtract 1/9 from each side, I get sine squared of theta. 1 minus 1/9 is 8/9. And since we have sine squared, we square root both sides. And we can do each numerator and denominator separately. So our sine of theta is going to equal the square root of 8 over the square root of 9, which is 3. And if we want to simplify that square root of 8, 8 is 4 times 2, and the square root of 4 will come out as a 2 times the square root of 2 over 3. So we found sine of theta, just given cos is equal to 1/3. For part B, tan of theta, well, tan is also the same as sine of theta over cos of theta. So sine of theta we just found was 2 root 3 over 3, divided by the cosine of theta, which is 1/3, which was given to us right here. And a fraction divided by a fraction, we invert and multiply. So I'm going to bring this 1/3 up and flip it, make it 3 over 1, and multiply. These 3's will cancel, and it'll be 2 square roots of 3. So tan of theta is 2 square roots of 3. For part C, secant. Well, secant and cosine are reciprocals. So if I have cosine and I want to find secant, I take cosine and flip it over. 1 over 3 becomes 3 over 1, or just plain old 3. For this, we want the cosecant of the complement of 90 degrees minus this angle theta. This, if you go back to yesterday's notes, we will see that the cosecant of some angle is the same as the complement of secant. So here, secant of theta we found to be equal to 3. Well, the cosecant of the complement is the same as the secant. So this cosecant of 90 minus theta is the same as this. It's equal to 3. And that's it. In this second one here, they say transform the left side into the right side. So here on the left we have a cos of theta and a secant of theta. On the right we have 1. We want to mess around with this left-hand side and try to transform it so it'll look like the right-hand side. And this is a pretty straightforward one. If possible, a good strategy is to try to turn everything into values of sine and cosine. So this cosine of theta we're going to leave alone. Secant of theta, well, that was one of our identities. The secant of theta is the same as 1 over cos of theta. So here we have cos of theta times 1 over cos of theta. And don't forget, we can put a 1 under this if we want to, and if we multiply straight across, we get the cos of theta divided by the cos of theta, and no matter what, anything divided by itself is equal to 1. These last 3 are just, some practice pushing the buttons on the calculator. For the cotan of 45, if you do it right, you should get a 1. The cosine of 45, 0.7071. Most time trig functions are written to 4 decimal places. And the cosecant of 45. Remember, there's not a cosecant button. So I'd find the sine of 45 degrees, and then use the invert key, the 1 over x key, and you should get 1.4142. So just some extra examples similar to what you might see in the homework. Here are some Huddle problems. Pause the video, give the problems a try, then unpause the video, come back, and see how you did. So here in the first one, if we read the directions, use the given function values and the trig identities, including cofunction identities, find the indicated trigonometric functions. So we're given that sine of 30 is a half, and we know that the tan of 30 is root 3 over 3. So we want to find the indicated trigonometric. So I don't think I copied this entire problem. Well, first, let's find the cosecant first. Cosecant. And that should be an easy one. The cosecant of 30 degrees is just the inverse of the sine of 30 degrees. So we just flip that over. 1 over 2 becomes 2 over 1, or just plain old 2. For part B, they were asking us to find the cotan of 60 degrees. Well, cotan and tan are reciprocals, or not reciprocals, and we see that the 30 and 60 degrees are complements. They do add up to 90, so the tan of 30 and the cotan of 60 are going to be exactly the same, the square root of 3 over 3. And let's finish up here and find the cotan of 30 degrees. Well, we have the tan of 30 degrees. Tan and cotan are reciprocals. So if I flip the tan over, I'll get the cotan of that same angle. So I'll turn it over and get 3 over the square root of 3. But we have a radical down in our denominator. Leaving it there would be bad math manners. So we multiply by root 3 over root 3. And we will get 3 square roots of 3 over square root of 3 times the square root of 3 is the square root of 9, or 3. And then these will cancel. So we're just left with the plain old square root of 3. In the next Tuttle problem, use the trig identities to transform the left side into the right side. Again, a nice strategy, the first route I always take is to try to write everything, if possible, in terms of sine and cosine. So tangent, if we go back to our first page in our notes, we know that tangent is equal to sine over cosine. And this is already cosine, so let's leave it as cosine of alpha and put it under 1. Put it over 1. And now here on the diagonal, we were going to see these cosines are going to cancel. So we're left with, if we multiply straight across, sine over 1. And that's equal to the right side, which we were trying to transform it into. This last Tuttle problem here, again, it might help to go back to yesterday's notes. Find the values of theta in degrees. You know, we want our angles to be between 0 and 90 degrees, or 0 and ½ pi radians. So we are in the first quadrant. We want to find the value without using a calculator. So if we go back to our table where we can look these up, if you look up tangent and you see the square root of 3, you'll see that that occurs when theta is equal to 60 degrees. Or that is equivalent to 1/3 pi radians, pi over 3. Cosine of a half. Again, if you go back to the notes from yesterday and look through the table, you're going to see that cosine is a half when theta is equal to 60 degrees, or pi over 3 radians. The assignment for tonight, 17, 23, a few other problems here, 27 and 28. Make sure you're using a calculator on those.